The next person I want to introduce to you two joined Esri last year. She is now our chief scientist. Her name is Dawn Wright. She is a geographer and an oceanographer. She is a wonderful person, and she's going to share what she's doing at Esri in terms of pushing us towards the blue stuff. Dawn Wright. Thanks,
Jack. Thanks so much, Jack. Well, for many of us, when we think about the oceans, it's a situation of out of sight, out of mind. We see only the surface, think only of vast expanses of lifeless water, not realizing all of the complexities at play. But in fact, the oceans provide over half the oxygen that we breathe. They regulate all of our weather patterns, they feed us, they provide for our energy and economy. So in reality, the oceans are vital to all of us, no matter where we live. This year, there have been many stories in the news about the estimated 1.5 million tons of debris headed to the U.S. and Canadian West Coast now from last year's Japanese tsunami, as you can see from the simulation above. The pictures below show some of the debris already washed ashore in Oregon, Washington, and Alaska. And one of the big surprises here has been the sheer number of living sea creatures attached to these debris, some of which are invasive and could devastate local populations. Indeed, the issue of marine debris is one of many challenges facing the ocean today. GIS has long since provided effective solutions to similar problems on land, but our mission now is to take what we've learned on land and apply GIS more effectively to the oceans. But this is hard. It's a hard mission because the oceans present to us some very challenging 3- and 4-dimensional problems. They're very hard to access at full depth from the sea surface down to the sea floor. Satellites and LiDAR, for example, can't see all the way through the water in all places. So as a result, only 5 to 10% of the oceans are mapped in the same level of detail as on land. But this mission is totally within our grasp. As we know of GIS on land, we build upon the foundation of topography, and in the oceans, it's bathymetry. The Esri Ocean Basemap project continues to use the world's most authoritative bathymetry as contributed by the international hydrographic and scientific communities. And we're adding new high-resolution data all the time, as you can see from the boxes here, and we very much welcome new contributions, such as these data from offshore of New York City, contributed by our friends at NOAA. This is, in fact, the undersea equivalent of our Community Maps program. We also have new GIS tools, such as ArcGIS for Maritime at 10.1, which helps us to update our ocean base map, to integrate, merge, manage, share our data, our bathymetry, to make sure that our bathymetry is fully functioning with the new tools and data models that we're creating, to connect with the water column as well, and to create more accurate nautical charts. There's further hope in the growth of ocean science with GIS. These labs and agencies, for instance, are showing the way via their terrific work throughout the Atlantic Ocean, analyzing plant and animal species diversity and distribution, developing numerical models of ocean currents, and predicting where coastal erosion will occur. In the Western Pacific, GIS analyses of the ocean floor have helped to discover over 50 new undersea volcanoes and rift zones in this very geologically active part of the world where major earthquakes and tsunamis have caused great devastation. And in the Arctic, where global warming is occurring here 2.5 times faster than other parts of the world, the interests of oil and gas, shipping, fisheries, tourism, conservation, and international politics are all being very carefully analyzed with GIS. And many of these groups are working together to best deal with oil spills that could occur both on and under the ice, something that we're still totally unprepared for. Esri is supporting the University of California at Santa Barbara in building a new approach to marine spatial planning based on the concepts of geodesign that you just heard about. This is a great web-based solution called SeaSketch, and it leverages the ArcGIS API for JavaScript, ArcGIS Online, and the Esri Ocean Base Map. And it'll soon be used for ocean planning in New Zealand, the Galapagos Islands, the Cook Islands, and many other parts of the world. So we'd like to show it to you now, and it's my great pleasure to introduce Will McClintock, the project director of SeaSketch, and Chad Burt, the lead developer of SeaSketch. Will, take it away, please.
Thank you, Dawn. Out in the Santa Barbara Channel near where I live, there's a whole bunch of things going on. This is an area that's rich in biodiversity and recreational opportunities. We've got offshore oil and gas facilities, major shipping lanes, and ports. And we have marine protected areas around ecosystems that are often described as the Galapagos of North America. But my friends at the Channel Islands National Marine Sanctuary have pointed out that sometimes ships run into whales. And for endangered species like the blue whale, this is a real problem. Obviously, nobody wants to kill blue whales, and one simple solution might be to move the shipping lane from the center of the Santa Barbara Channel to the backside of the Channel Islands where there are fewer whales. The problem there is that we'd be sending ships through a military test fire range, and we might be costing shipping industries significantly more in travel time. So, to find a creative solution to this problem, we'd like to include as many people as possible in this discussion. The challenge there, of course, is it can be difficult to get all the people affected by this decision into the same room at the same time, looking at the same information. So we've designed SeaSketch to allow people to collaborate remotely. And to demonstrate this, I'm going to post a message to a forum and invite folks to join me in the design of a new shipping lane. Now, when I post this message, it's going to include a bookmark to my map and my active data layers. I'd like to work with Chad, who's all the way on the other side of the stage here, but he could be anywhere in the world. And we're going to work collaboratively, so I'd like to bring up his screen too.
Thanks, Will. I'll just find that topic in the discussion forum and click on the map bookmark. And this is going to activate those layers that Will was looking at, so we're looking at the same view of the information. I can then use those layers as a reference while using the sketching tools to digitize a new shipping route. I'll try to avoid those areas where blue whales are most commonly seen. And SeaSketch is going to transform my simple input into a ship traffic separation scheme. It will also guide me through entering in any necessary attributes. With that saved in my account, it's easy to take my design and attach it to a reply in the forum. And with this reply, I can easily share my ideas with Will.
Great. I can see Chad's design, and I can also run a report that's going to tell me how well we've done at reducing the probability of blue whale strikes. That part looks pretty good, but there's a problem here. His proposal overlaps the safety area around an oil platform. This kind of real-time feedback is central to the process of geodesign, as we've just heard. What I'd like to do now is improve on Chad's design a little bit by copying it and then editing the geometry so that we miss those oil platforms, hopefully. And when I'm done, I'm going to rename it, call it Will's Design, save it back to my account, and share it with Chad so that he can use it further.
And there's Will's design on my screen. So what have we done here? We've just collaboratively designed 2 alternative shipping lanes and performed geospatial analysis to see how those prospective plans might impact blue whales and the shipping industry. I can pull up the reports for both of our designs and see that we're working towards a better solution. We can take this same collaborative geodesign approach and apply it to all other activities in the channel to plan for fishing, aquaculture, military activities, and energy extraction. The process works great at a small scale, like we've just demonstrated here, but more importantly, we can scale it up to support many stakeholder organizations and thousands of users, leveraging all their collective knowledge in a decision-making process. We're really excited about the real-time features of SeaSketch because it will allow those same users to collaborate remotely as if they're all sitting around the same table, looking at the same maps, designs, and reports.
So does collaborative geodesign really work? Can we really involve thousands of individuals and organizations in the collaborative design of new marine spatial plans? Absolutely. California has a brand new set of marine protected areas that were designed by hundreds of organizations and individuals in California using collaborative geodesign technology. So now we're excited to bring SeaSketch and geodesign to oceans around the world. Thanks, Don.
Thanks so much, Will and Chad. Thanks so much, Will and Chad. Well, we can't wait to see what's next. This is going to be awesome. Now, across the entire Esri organization, we have a new Oceans GIS initiative. And this includes a comprehensive strategic plan that you can read, a new Oceans Maritime Resource Center, and as you can see on the screen, we're working with a growing list of terrific partners. So now is the time, people. Now is the time for all of us to work together using geography as a platform to save and care for the life of our oceans for future generations to come. Let's do this. Thanks so much. Jack, back to you.
Yeah, let's do it.
Good.
Thank you, Dawn. Thank you. Isn't she great? I mean, amazing.